So hi everyone. So today I'm going to go over a brief introduction on Emco, followed by the Emco 2203 release, the features that have been introduced in this release, features and enhancements rather. And then we are going to go over a demo, and the demo will basically show a subset of features which are part of this 2203 release. Starting with the introduction of Emco. So Emco is a multi-cluster orchestrator, and Emco is basically meant for multi-cluster distributed applications. Emco can orchestrate applications across edge clusters, and along with orchestration, Emco also manages the life cycle of these applications. Emco is a platform, and it is an extensible platform, extensible in the sense that the functionality in Emco can be enhanced by the means of the controllers, which are called the Emco Controllers. So on this screen, what we see is in the northbound, Emco provides both the CLI and the web GUI interface. And underneath, Emco has the main component, which is the orchestrator. And along with orchestrator, there are multiple controllers which can be onboarded based on the use case. And as I said, each controller will basically perform the specific operation in service orchestration and the lifecycle management. To name a few of the controllers, so there is a cluster registration controller, and this controller enables users to onboard the target Kubernetes clusters to the platform. And in order to onboard a cluster, the artifact that is required is the kubeconfig file of the cluster. And then there is another controller, which is the network configuration and management controller. So when there is a requirement to create secondary networks, or the other way of saying this is for the services and applications which we are orchestrating through Emco, if they require secondary interfaces, via this controller we can automate the whole operation of creating these secondary networks, creating and managing these secondary networks across all the edge clusters which are target for this for these applications. And once these networks are created, the later during the service instance creation, when we are about to deploy the services in the target clusters, there is a provision to the specify the information about the interfaces which the application is going to use. And using that information underneath, the Emco will basically via the CNIs which are deployed in the target clusters will create the secondary interfaces of these applications. And similarly, there is hardware platform aware controller. This controller helps in specifying the placement intents, and the placement intents can be specified as a property of the target cluster, and based on as a property which is basically owned by the target cluster. So in this case, what we can say is I want to deploy my application to a cluster which has hardware accelerator, for example. And internally, Emco will figure out and deploy the application to a suitable cluster. Distributed cloud manager. So this cluster basically it provisions the users to create logical clouds, and I will explain what logical clouds are in further slides and even in the demos. So it is basically stitching the clusters that we have that we onboarded that we onboard on this platform. And so yeah, so more on logical clouds is there in the following slides. So yeah, so this is an introduction on what Emco is and what Emco uh, enables users to do. In the 2203 release, there are new features and enhancements. The first one is a new feature, which is the GitOps integration with Emco. So now what we can do is we can mark the clusters, the target clusters to be GitOps enabled. And what that will give the users is that the resources that we are now creating via Emco. By resources, I mean the services and all the Kubernetes objects. So those resources are now GitOps, when they are deployed in this target cluster, they are GitOps enabled. So what it means is that these additional controllers, which are now deployed in the target cluster, they will push all the resources that are created to the GitOps in a specific directory structure, which is explained in the documentation. And from then on, any pull request to these resources in the GitOps will be reconciled by the agents like Flux v2 in the target cluster. So this will basically enable the whole continuous deployment cycle. So this is a new feature. Modify instantiated logical clouds. So this is an enhancement. So until now, the logical clouds that we could create in Emco. So there are two kinds of logical clouds: standard and admin. So admin logical clouds, basically it gives the it basically enables or gives the provision to a cluster. It gives a cluster wide authorization to the user. What it means is using a admin logical cloud, the applications can be deployed in the default basis, and there is no limit on the resource, or uh, there are no service accounts or rules that are created. So it is like the user has the cluster wide permission through these clouds, hence they are called admin level logical clouds. And standard logical clouds are basically, so the user has to specify a namespace and also specify quotas and permissions. Quotas, the quota by quotas, I mean resource quotas, and permissions as in permissions permissions about what kind of Kubernetes resources can this specific user access and create. So this is the standard logical cloud. So until this release, once a logical cloud is created, what it means is the clusters that I am adding in this logical cloud, uh, there was no provision to modify it. So for example, if you create a logical cloud using two clusters and you specify quotas permissions, then that is about it. There was no provision to basically modify the instantiated logical clouds. Now with this release, that feature is enabled, and the logical cloud can be modified, edited throughout its life cycle. This is an enhancement. Third one is again an enhancement in the status query and notification part. So in Emco, the status about the resources that are created by Emco is provided by an agent which is called the monitoring agent, which is deployed in the target clusters along with the uh, along with the applications that we orchestrate. And this monitoring agent is basically monitoring the Kubernetes resources that are created. Now with this enhancement, there is this enhancement will basically enable the application writers to or notifications about the status of specific resources that are created by Emco. So this is an enhancement, and the monitoring agent and status query, this was all part of Emco until this release. Now the subscription for notifications and enhancements in the status API itself are the new additions in 2203 release. And when it comes to the web user interface, so on web user interface, there are new features that have been introduced, and the first one to start with is the RBAC. Now there is role-based access on the GUI, and that we will basically see in the demo. So I'll explain in the demo. Standard logical cloud. So until now, so as I explained, there are two kinds of logical clouds, admin and standard. Until now, on the GUI, only the admin logical clouds were supported. Now the standard logical cloud has been integrated as well, because the standard logical cloud is tightly integrated with the whole RBAC flow. So along with RBAC, I mean, once the RBAC is implemented, the standard logical cloud integration had to be done. Service discovery via the service discovery on the GUI. So AMCO has this controller which is called the distributed traffic controller. It is an umbrella, and underneath the DTC controller, there can be multiple subcontrollers. So this very specific subcontroller, which is called the Istio traffic subcontroller, is what is integrated with the GUI now. So so functionality wise, what it gives you is for the requirements wherein we are orchestrating applications across multiple clusters, and wherein the applications are reaching out to other applications over the DNS name. So the service discovery has to be there. Otherwise, the applications will not be able to reach out to applications which are present in the other clusters. So service discovery is implemented in AMCO via the Istio way. So underneath Istio is what is deployed in the target clusters. And when you deploy applications across multiple clusters, during the service instance creation or the deployment intent group creation, there is this new intent that can be specified, and that is called the DTC intent. And in this intent, you can specify that you want to expose this application. And internally, AMCO will create all the required Istio resources in order to make this service discovery possible. And to be specific, what it creates is the service entries for the external services. And by external, I mean the applications which are basically present in other clusters. Okay, that is about the GUI. Temporal workflow engine. So there is this is a new feature, a new controller which is added in AMCO. So using this controller, users can basically orchestrate and manage the workflows, which are the temporal workflows. And so in target clusters, the temporal related engine and temporal related applications have to be deployed. And AMCO basically tightly integrates with temporal via this controller. And based on use cases, I mean specific use cases, users can write workflows and orchestrate and manage them through the AMCO platform. And along with this, there are other enhancements, improvements, bug fixes, and like one of them is in the generic action controller, for example. Yeah, so this is about the enhancements and features in the 2203 release. So the demo that we are going to show will basically show subset of these features, because covering all these enhancements and features in one webinar or in one demo is difficult. So we chose like this for this session. This is what we are going to show. So in the demo, so these are the features, I mean, which we will show, which is RBAC, standard logical cloud, and the service discovery feature. So to summarize, in the demo, what we are going to do is we are going to log in as admin, and then we are going to basically onboard the controllers first. And so these are the controllers which I explained. And to name them, basically rsync is one, and the DTC. DTC is because because this demo is about the service discovery, and that is the controller required for service discovery. And then as the admin, we will also create a user, and we will also create a tenant which this user will belong to. And AMCO is a multi-tenant orchestrator. So then, yeah, we will log out and log in as that user, and we will see the resources which belong to the tenant, which we just which we create. And then we are going to orchestrate two applications, a client and a server, across two clusters, and across two Kubernetes clusters. And then we will see that, and these are very simple applications which are only meant for like this demo. And how these applications function is like the client application, it is continuously doing curl on the server application over its DNS name. Since the application is not present in the same cluster, the client is still accessing HTTP slash server colon port, which is present in the other target cluster, other Kubernetes cluster. Because we specified the service discovery intent, and AMCO internally created all the Istio related constructs, which is the service entry. We will see that the client will be able to reach out to this HTTP server colon port, which is in the other target cluster, and that will basically show the service discovery part. So with that, I'm going to jump onto this demo. This is a pre-recorded demo, and I will talk through this video. So this is the AMCO login page. So we will log in as first time user admin. So after logging in, the first thing that we are doing is we are creating a new tenant, and under this tenant, basically this is the tenant we will use for orchestrating the client and server applications. Now we are onboarding the clusters. So to start with, we are onboarding the rsync cluster, the resource synchronizer. This is the generic action controller. In this demo, we are not going any use of this generic action controller. So this is the traffic controller, and this will basically enable the whole service discovery. So after onboarding the clusters, after onboarding the controllers, so now we are going to basically instrument these clusters. So there are these four clusters, and for onboarding the kube config file of these clusters is used, and the 192.168. So it is the name of the cloud provider. It should be a name and not an IP address. For demo purpose, since this process is automated, the automation scripts basically create this as IP address. So what we see on the screen is that under the cloud provider, like 101.2.2.2, we have these four clusters. And now this demo, since this demo is about the service discovery, so one prerequisite for service discovery is that we have to basically put information in the cluster about the load balancer IP of the clusters, which will host the servers, right? Because internally, if you see when we create service entry and when we are accessing applications across clusters, The IP address that is used is to reach out to the server application in target cluster is the external IP of the Istio ingress. So now we are just putting that information. So this, what we see on the screen is that we are adding key value pairs, and it is not only meant for this use case. We can add key value pairs for like other use case also, and this information can be used in the like in Emco based. And if you are writing a new controller and you want to basically have some metadata about your clusters which you want to consume internally, this is the way we can add key value pairs. So now we are going to add the user. So we are going to assign this user to this tenant that we had created, which, and now we will log out and log in as the user. So this is the tenant view, which is different from the admin view. Under this view, we will see resources, only those resources which belong to this tenant. And primarily those resources are the logical clouds, services, and service instances, which belong to this tenant. So now we are adding creating the service. So in this use case, we are going to create a service with two applications, client and server. And in Emco, in order to onboard an application or to create a service, the artifact that is used is the Helm chart. So now we will upload Helm chart of both the client and the server. And along with the Helm chart, we will also upload the profiles. So profiles are a way to override the default values in the Helm charts. So this created the service for us, and we can create multiple instances of this service, runtime instances, and we can specify different intents for different instances, and based on our requirement and use case, the instances will be instantiated as per the placement intents and other intents that we specify. And there is also a provision to basically edit or update or upgrade these services. We can check out these services and update the Helm charts, and that will basically create new version of this. And later we can choose to use any of these versions when we create the service instance. Now we are going to create the logical cloud. So we are creating a standard logical cloud, and demo is the namespace that we create, and we have chosen two clusters to be part of this logical cloud. And in this demo, later we will see that each application goes to their own clusters. And we are enabling service discovery in this logical cloud. Now we are ready to create the service instance. So this is the form to create the service instance. So we are choosing version 1, and this is the logical cloud. And at this page, we will specify the per application intent. And in this demo, there are only two kind of intents that we are going to specify: the placement intent So for server, we are choosing cluster 2, and client, we chose server cluster 1. And now we are specifying the service discovery intent. And via this intent, what we are saying is that enable service discovery on my HTTP server service. This is the information that is required. So now we are instantiating, and in the backend, Emco will deploy the services to their clusters. So this dashboard shows that it is the services are instantiated, and client is in server 1, and client is in cluster 1 and server in cluster 2. So now we can see the logs of cluster 1, which should show that it is able to reach out to the server, which is in another cluster. So applications. So this we are showing that these are the service entries and destination rules which internally the DTC controller created in both clusters. And this is what basically will enable the client to reach out to server across cluster. So now we will dump the logs of the client. So as I said, it is like simple application. It does a curl on the server, and this is what server responds with. So it is saying hello from HTTP server with the pod IP. So this is the pod IP of server in the cluster 2. And it reached out, and this is the pod name. So this basically shows that the client is able to reach out to server in the different cluster. And and this concludes my demo.
Okay. Thank you, Sandeep, for such a resourceful and neat detailing. So we will quickly jump to our QA session now.
Okay.
Okay, so this question has come. What is logical cloud? Yeah, hi. Sandeep, can you hear me?
I'm sorry, I was on mute.
Yeah. So there's a question which has popped out. They're asking me what is logical cloud?
Yeah. So logical cloud, as I explained, it basically is a way to stitch clusters together. And then that logical cloud basically becomes the target for a specific deployment intent group. And what it means is we can then orchestrate or place the applications which are part of the deployment intent group across any or all of the clusters which are part of this cloud. And the standard logical clouds are they are basically a kind of a distributed namespace with specific quotas and permissions. And that is.
Yeah, I hope it answers. Okay. What is an ITS controller?
ITS controller is the istio traffic subcontroller, and that is the controller which creates all the istio objects which enable the service discovery feature in Emco.
Okay. Any more question, audience? Okay, I got one more. What is a service discovery?
Service, I think I already covered this.
Yeah, that part. Okay. So yeah, if there are no questions more, I will be announcing soon the upcoming event on Meetup for 25th April. I'll soon see you there. And yeah, okay, there is one more question. 1 second. How Emco manage the CNF LCM? Panelist, anyone want to answer?
So yeah, so when it comes to lifecycle management, so there are two phases, day 0 and day 1. And day 0 is basically when we are orchestrating the applications, we can provide the configurations there. Configurations which are application specific. And the ways to do that is like, one is at the profile level itself, wherein we can override the default values in the Helm charts. And another way is the GAC. The generic GAC is the generic action controller. And generic action controller basically enables us to patch the Kubernetes resources, patch the YAMLs rather, JSON patch via JSON patching, and it also enables us to upload altogether new resources, new config maps or secrets, and they can be specified and uploaded during the service instance creation time. So that is day 0. During the day N, we can always, go and check out a service, and then we can edit the applications or edit the Kubernetes objects again via the generic action controller. We can either edit config maps, upload new config maps, or if there is custom resource, we can edit and upload that as well. So that is how the that is what Emco.
Yeah. Okay. Yeah. Thank you so much, Sandeep. So I'll see you all on 25th of April. Until then, goodbye and good day and good night. Thank you. Bye-bye.
Thank you. Bye.
Yeah.